Okay, so today too we are looking about um how we can use the D operator method to solve question in this form. That's in the situation where the right hand side is equal to sine x. So this is the general question. That's a 2D minus 3 multiplying y is equal to sine x. But I have written 2y prime minus 3y is equal to sine x to this one is just telling us that we derived the whole of this, the blue ink from this. So I just wrote this. The same thing. It's this one we derive the blue ink from this red ink. But this is the main question. Okay, so you see some of the examples here. So see there are a lot of examples here. Okay, that d minus 2 multiplying y equal to e point x and other stuffs. So you know that all this question, this, see, they all have the right hand side being equal to a trigonometric function, which is a cos and the sine and other stuffs. Okay, so when the idea of this, when we get the solution for this, then we can definitely apply for this, apply for this, apply for this. We can solve the rest. Okay, so quickly let's solve the second question, the one the fourth part, the one that I've underlined, that the 2d minus 3y equal to sine x. 2d minus 3y is equal to sine x. Okay, so what we intend to do is that we will try to eliminate the constant in front of the d. So what will you do to eliminate? You just divide both side by 2 to eliminate the constant in front of the d. So when you divide by 2, you are going to get d minus 3 all over 2, and this place 2, because remember you are dividing the whole of this equation. So sine x all over 2. So here you are going to get d, because the 2 is going to cancel the 2. So you get d minus 3 over 2 multiplying y is equal to half of sine x. Okay. So this implies that you just make y the subject from this place. So you are going to get 1 over d minus 3 over 2 operating on the r of x. So here the r of x is a half sine x. Okay. So we just compare it to a general form. We've already spoken about it. Um, d minus a, that's a constant of y is equal to r of x. You just make y the subject. We make y the subject, are going to get 1 over d minus a r of x, which is equal to, just maintain the positive value, which is e exponent positive ax, then integral of then the negative value of the a, e exponent the negative value of ax r of x. So that's what we are trying to do. So we just compare this one to this general form. Okay, so we know that your a is what? Positive 3 over 2. So here will become 3 over 2, here will become negative 3 over 2, and the r of x becomes half sine x. So that's what we have done here. Okay, so you know that the half is a constant, so half can come out from this equation after the substitution. So we are going to get half e exponent 3 over 2x multiplying the integral of the whole of this. Okay, e exponent minus 3 over 2x sine x dx. You know that this is integration by parts. The red, the one that have um circled it with the red ink, is integration by parts. Okay, so what we intend to do is that you just make the exponential part to be u, and you make the trigonometric part, that's the sine, to be divine. That's what you are trying to do. So your u become e x minus 3x over 2, then your divine becomes sine x. So you know that because the divine is equal to sine x dx, you can, this one is all the x out of the same side, and all the divine or the device of the other side. So it's separable. So you can integrate it by using method of separation. Okay, it has already been separated. So just integrate your divine, you are going to get divine. You integrate your sine x, you are going to get minus cos x. Anytime you integrate sine x, you are going to get minus cos x. Okay. So and here too the same thing. You had your u to be e exponent minus 3 over 2x. So just differentiate it. You are going to get, we maintain the e exponent minus 3 over 2x. Then you multiply by the derivative. But because when you differentiate the exponent, you are going to get minus 3 over 2. So you just multiply 2 by the minus 3 over 2. So that's what I have done it here. So just make this substitution for integration by parts. U v minus integral of v du. So wherever you see your u, this your u, just make that substitution there. Your v, this your v, make that substitution there. Then your v du. You know that this your v and this your du. Just make a substitution there. So that's what I've done it here. So e is my minus 3 over 2x, that's the u, then times the v. Now the v here is minus cos x, so times minus cos x minus the minus integral. So this is the integral of the v. Now the v is minus cos x here times du, and the du too is minus 3 over 2 e is minus over x. So that's here. Okay, so because this is a constant and it's negative, when it comes out it becomes positive, but here it is negative cos x, so the negative will still make the positive become negative. So you are going to get 3 over 2 out, then left with this. Okay, so still, we are not done. This is integration by part. That's the IBP. So we further on integrate this. So forget about the rest of this. Just concentrate on this. Okay. So the idea is that we will integrate until we get something the same thing as the original question or the original equation here. That's the integral of e squared minus 3 over 2 x sin x dx. So we just concentrate on this and integrate it again. Okay, so we are doing that. So we are just concentrate on that one. This one, we are just concentrating on this. Okay. So when the same method, you make your u to be the exponential part, that e squared minus 3 over 2x. So you differentiate u, du, you are going to get minus 3 over 2 es per minus 3 over 2s, because you maintain the es per minus 3 over 2s, then you multiply by the derivative of the power, which is minus 3 over 2. Okay, so here to your dividend will be your cos x. So when you integrate your dividend, you're going to get v, because they are separable. They've already been separated. All the dividends of one side and all the cos x and the ds is at another side. So by separation, there's no need to separate them again. So we just integrate them straightforward. You are going to get integral of cos x, you are going to get sin x. Then integral of dividend, you are going to get v. Okay, so your v is equal to sin x. Okay, so we just make that substitution again. That's u v minus integral of v du. Okay, so your u here is this, so that becomes your e exponent minus 3 over 2x times the v here is sin x, so sin x minus integral, so minus the integral of the v, and your v here is sin x, is the sin x, then the du, the u is minus 3 over 2, so here is the minus 3 over 2. So because here is minus 3 over 2 and it is a constant, when it comes out it becomes positive, because the nege po becomes positive 3 over 2 integral of the whatever here. Okay, so I wrote this one to be equal to integral of e squared minus 3 over 2 x cos x, because this is the result of the result that we had after integrating this one, after integrating this. Okay, so it's nothing. So we just make a substitution. So it means, as we said, now we have integrated this to get this. So just make a substitution backwards. Now we are coming to write the whole of this, but here we will not write integral of e squared minus 3x to cos x again. We will just, that one gave us the whole of this. So we just make a substitution for this. That's what I have done it here. Okay, so now your integral of e exponent minus 3 over 2x sin x initially is now equal to this part, the whole of this. We have forgetting about this. We want to do this, and after that, to multiply through by this. So we know that the whole of this gave us this, the whole of this, and we further on integrated this. Then we had this. So we are just come to make a substitution here. It means wherever you see the integral of cos x, you are going to make this substitution there. So that's what I've done here. So the integral of e minus 3 2x and x is going to get minus e exponent minus 3 over 2x cos x minus, so this one minus e exponent minus 3 over 2x cos x minus the 3 over 2, and that 3 over 2 is multiplying the whole of this. And remember, we've gotten an expression for the whole of this to be this. So we just multiply the 3 over 2 by the whole of this expression. Okay, the whole of this expression, which is this. Okay, so that's the idea. Okay, so we are going to get integral of the e exponent minus 3 over 2 sine x. That was the original question that we were to integrate. Okay, then we now gotten this expression multiplying minus 3 over 2. So we just multiply through by the negative 3 over 2. So you are going to get minus 3 over 2 e exponent minus 3 over 2 sine x minus 3 over 2 multiplying this. You are going to get 3 times 3. You are going to get minus 9. Minus 3 times 3, you're going to get minus 9. Minus 2 times 2, you're going to get 4. So we get minus 9 over 4 here. Then integral of the e exponent minus 3 over x and x. Okay, so what we are trying to do is that, you see, because we obtain a, a certain variable or a certain answer here, that's the e is minus 3 over 2 x and x. It was similar to the original question that you were to integrate. You see, it's the same thing. Let me use that term. It's the same thing. It's the same thing. That's why we didn't integrate it again. So that's the whole idea. Okay. So we try to, because you know that integral of e x minus 3x over 2 sine x is here, integral of this one 2 is here. So we just factorize. Yeah. So this one will come here. Okay. So the whole of this one is here. Then when this one minus, when it comes become positive, then you maintain the rest of this one. Okay. Okay, so yeah, when you add integral of this one plus integral of 4 over integral of the whole of this, when you add the whole of this, you are going to get 13 over 4, because you know that the constant here is 1. Okay, so 1 plus 9 over 4, you're going to get 13 over 4. Then because they are the same, just choose one, because integral of e minus 3 over 2x sine x is the same repeating, so you just choose one. Okay, then add the coefficient, which is the 1 plus the 9 over 4, getting 13 over 4. Okay, so you are going to get this place equated to this place, that the minus e exponent minus 3x over 2 cos x minus 3 over 2 e exponent minus over 2 sine x. Okay, so now what we intend to do is that we want to make this the subject. Okay, that's the answer for the integral. Okay, so we just divide by the constant here. But you see, when you divide by this, the 4 will come up and the 13 will come down. So the 4 over 13 will come and multiply the whole of this. Okay. So now we are remaining of only the integral part, and this one is now equal to this. Okay. So you just multiply 2 by the 4 over 13, the whole of this equation by 4 over 13. Okay. So I think when you multiply through, you're going to get minus 4 over 13 es minus 3x cos x. Then 4 over 13 times minus 3 over 2, you are going to get minus 12 over 13 times 2, you are going to get 26. That's what I've done here. But you are going to get the 12 over the 26. 2 will go into the 12, 6, and go into 26, 13, right? Sine x plus c. Okay, but remember from the previous equation, we had the half of the e exponent positive 3 over 2s multiplying the whole of the integration. The whole of the integration, this place. Okay, it was e exponent 3 over 2x multiplying the whole of this. Now the whole of this has been simplified to this. So we just multiply 2 by the half e exponent 3 over 2x. Okay, simple for us to get our answer. So we multiply this one, half e exponent 3 over 2x by the whole of this, the positive and negative 3 over 2. So you add them, it becomes e exponent 0, and e exponent 0 is 1. So that's why I didn't write it. So it will be left with only the cos x. So cos x, right? Okay. So then the half of the minus 4, half times minus 4 over 13. You are going to get 4 over 26, and 4 over 26 you are going to get the same thing as minus 2 over 13, because 2 will go into 4, 2, and go into 26, 13. Okay, so I didn't write it. Okay, then half times 6 over 13 to the same thing. You are going to get 6 over 2 times 13, which is 6 over 26. Sorry, 6, yeah, 6 over 26. Okay, so 3, sorry, 2 will go into 6, 3, and 2 will go into 26, 13. Okay, sine x. Then the half e exponent 3 over 2x will multiply the constant. You are going to get half c e exponent 3x. Okay, so we can say half c is a constant. Okay, so we can donate it as, let's say, c1. So this becomes our answer to the question. So this become the answer to the but the question. Yeah, so that's the answer. Okay. Thank you very much.